Today on CHOP, the main types of molecules that we'll be working with are carbohydrates and lipids. An example of a carb in our recipe is sugar, and an example of lipid is the buttery oil at the bottom of our pan. Throughout the show, we'll show you how these molecules interact and how they will help one of our contestants become this season's champion.
Hello, and welcome to CHOP. Today we'll be making French tips. Our contestants today are Leah and Francesca.
However, for this show, we have a slight rule change. The two contestants will be using different ingredients from their baskets. Chefs, open your baskets.
Yay! What are you talking about? Looks pretty good to me.
Chefs, you may begin.
I'm putting butter into a pan on low temperature.
Leah will be cooking with a stainless steel spatula because it has a relatively low level of thermal conductivity, making it safe to cook with. The flame on the stove heats the pan, which speeds up the rate of collision amongst the molecules, thus showing the presence of conduction in this recipe, however not the materials used.
The fire underneath the pan heats the pan, which heats the butter, by increasing the temperature of the molecules of the butter. They begin to speed up until they reach their melting point, where the butter goes through a phase change from solid to liquid. First, I am breaking the egg and I am putting it into a bowl. Okay, and then I'm breaking another egg and putting it into a bowl. And then I am stirring the egg and making sure the yolk is broken and fully mixed with the whites. To do this, you add a splash of milk. As so. Okay. And you mix some more. And now here comes the fun part. Okay? Now you take cinnamon. A lot of cinnamon in there. Like a solid 10 shakes. Okay.
In this step, Leah's putting a solute, the cinnamon, into a solvent, the mixture of butter and eggs.
Okay. Then you take a little vanilla. You put a drop of it in there. Okay. And then you take sugar. You put a dash of that in there. And then you stir it all around. And make sure you get the sides of the bowl. Nice.
As you can see, the ingredients in Leah's bowls have similar polarities as everything is coming together into one mixture. This is proven by the like dissolves like theory.
Okay, the first thing to make French toast, you're gonna need a lemon. You're gonna need to cut that lemon in half. And then you're gonna need to squeeze the lemon juice in there. Okay, then you're gonna have to squeeze the other lemon juice. I'm using lemon juice. This strong acid has a pH of 2, giving it a strong sour taste, which will add an interesting flavor to this odd mixture. I will also be adding dish soap to ensure that the bases, my favorite part of the pH scale, will have some representation in my dish. The next ingredient is ketchup. Add a little bit of soap.
As one can see from the egg that was dropped in the ketchup, Francesca's solution has a very low viscosity.
Oh my gosh, I forgot the main ingredient!
Wait, Francesca!
Now that you've got a little bit of grass and dirt, you just shove it in and mix that all together.
Here on the skillet, the ingredients are undergoing a chemical change. The ingredients are chemically combining as heat is added from the fire.
After 3 to 5 minutes, you're all done. Next, put powdered sugar and cinnamon on top and use 3 tablespoons of syrup.
That's an excellent volume of syrup.
So far, Leah is way ahead of Francesca. Leah's solution looks very professional, whereas Francesca's does not. We can see how limited reactants are killing Francesca. as she does not have enough bread to make French toast.
Because we're definitely not going to eat Francesca's French toast, we're going to put it through a malleability and ductility test instead. So Taylor's going to hit it with a mallet and we're going to see what happens.
I have lemon all over me. Oh!
Okay, alright, it's good.
The tool we use for this is a mallet, as it is very top heavy and thus excellent for transferring kinetic energy.
Well, this is definitely not malleable, as it cannot be shaped into anything without breaking. As you can see by this, it is also not ductile. As it cannot be spread into wire, it just gets splattered and does not stay together.
Now it's time to try Leah's French toast. We can see the heat coming off of the French toast, proving that it is exothermic.
Okay, there it is.
This is disgusting. It doesn't even trigger your gag reflex. Mine's way better.